Million to power millennium. Good morning. Namaskar. This is Engineer Suraj Singh speaking from Bharat India on this day, April 24, 2022, Sunday 3:12 AM. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक अप्रैल 24, 2022 रविवार सुबह के 3:12। Back to you with saying as usual. Title being Real Quality Requirement, Coordination Engineering, Only Way, Projects, Works, Designs, Contracts, Reliable Engineers, Power of Communication. Covered in this talk. Let's hope signals help. Before going further, I'd like to introduce myself again. That I'm Suraj Singh, FI Fellow Institution of Engineers, Chartered Engineer India, International Professional in India, Arbitration Engineer, Civil Engineering, and my email ID is suraj, SURHA _engineer@yahoo.co.uk, and this is my telephone number and address. Then there is certification of International Professional Engineer India, and this is certification of Chartered Engineer India, and this is certification of Arbitration Engineer Study. This is quality file, coordination file. I'm again saying this my again Suraj _engineer Suraj remember Suraj _engineer @yahoo.co.uk. This is arbitration certificate, arbitration engineer certificate, actually arbitration engineer, and this is international professional engineer certificate, which is valid for 5 years. And this certificate of arbitration engineer is valid up to age of 80. Automatically expires when one gets into 81. I'm 68 now, and this is Chartered Engineer Certificate, which is linked to corporate membership of Institution of Engineers India. It says by virtue of qualification, professional training, and corporate membership of Institution of Engineers India, this person is authorized to use silent title of Chartered Engineer India. And I close this file now. And it's not quality file Bharat India speaks about. I say every day Bharat India speaks about, but everybody should speak about this because real quality and real coordinations are required, and coordinations means reliable coordination, engineering projects, public and engineers. This is required. Reliable quality engineering works deliveries. Reliable coordination engineering as a must. A professional engineering, no, it is. You can say, if we miss real quality, if we miss real coordination, missing good engineering, and everyone should work on quality. You may be engineer or you may be otherwise. Quality has to be learned by everybody. Engineer is born, engineer is supposed to know how to apply quality, and before application one has to know what is criteria of quality in whatever involved activity. We should not stop bad quality. We should stop it. We should say question, should we stop or not stop? Answer is we have to stop bad quality. We have to start converting quality of every good before it is being produced into good quality. Because without quality your good has got no value. If you don't produce quality good, there is no export value. People won't require it. Maybe once they are, they buy your product, keeping in view is cheaper or let us try, it's like that. But remember, you have to build trust among your customers, and if you do not make trust, if you do not earn trust, you won't have any market in future. Trust travels long distance, while mistrust does not travel any distance. Remember, trust travels long distance. Just like say long distance horse race, it is this horse can race for long distance, which means short distance race has got no meaning. So everybody should be serious about this issue, because quality and coordination cannot be compromised. Coordination is that branch of, actually it is very much technical engineering activity. Without coordination we cannot do anything. Coordination means collection of required information and procuring it and focusing on information at one place. That focusing is very important, and it depends on what activity we do. Every activity has got different focuses. Person who does work, it may be engineering person or otherwise experience-based technician, everybody knows what is required on that activity. Person is trained accordingly, but how is it slackened? It's unclear. When you know this information is not available, it is very much true that you cannot do that job. And if you assume something, it is subject to risk that you may do bad job. Therefore, coordination is very much technical, I again say. It's not only technical, it requires certain mindset also. And once, maybe first time you delay something, but once you come into streamline that work naturally, and of course based on experience, further and further attempt would help, and you will be very fast one day. Quality moves on and quantity moves on. It will be like that, both move simultaneously, and that is basic principle, that quality and quantity must move together. No one should lag behind or no one should lag ahead. If quantity lags ahead, means quality is left behind, and if quality lags ahead, that means quantity is lagged behind. Yes, if quantity lags ahead and quality is maintained, there is no problem. But if quality is lags but quantity only moves away, there's a problem. That's why first of all we have to understand meaning of coordination, and then we have to apply on quantity. Without coordination nothing can work, and coordination means interactions and link and chain of informations required for whatever activity is to be performed. Coordination is a concentrated effort. Coordination means you have to concentrate on that work, and that is really very difficult. You may have many coordinations at one time for many activities. It is done, no problem. Once you are experienced, you can coordinate, because 60% of work shall be known to you, and you can coordinate. You know which information can be available or which can be extracted from this portion of project or this drawing or this specification. That information one got. So we can collect those points at one from every available information, and then understand what information remains there and what is applicable, what's not applicable, what's right, what's not right, what can be exempted, what can't be exempted, or what clarification is required for something absent. And that's where coordination moves. And once you get when you get correction, or once you get information, once you get clarification, then you can say, okay, I got information and can work on this. It looks very exclamatory, or you can say, you may think that I'm talking about this, I'm explaining in depth. Well, it's in depth, of course. Coordination means in depth you have to go. You should remember, if in engineering work is done wrong or deficient, correction of that work or remedial action on that works are very expensive, cost-wise and time-wise, and correction is very expensive, and it impacts adversely upon reputation also. Therefore, to produce quality work, to produce production, to produce quantity work, we must coordinate everything technically as well as otherwise. And therefore, first we have to understand coordination and which is missing. And I have experienced that on internet no much information is available about conduct of coordination. This means people are not doing it, or even if they are doing it, they do not project it to people who seek what coordination is. I am talking of engineering coordination because Engineering is production, engineering is industry, engineering is construction, engineering is involved everywhere we do work in our life. And if coordination is not done, this means quality cannot be obtained. Quality is objective along with quantity. You may say production means quality plus quantity, and both are dependent on coordination. Coordination job is very, very difficult. It's very, very technical. It's required complete concentration, and if we do not do that, we cannot coordinate. It doesn't happen. We cannot do it. That point is really very much important to be clarified and understood. Coordination is life, in fact, for an engineer. I've experienced that every engineer has to coordinate. You are in design, you work in design, you work on project, you work in production, you work in planning, you work in quantity, you work in safety, you work wherever you are interested in or you are expert of. You cannot avoid coordination. Coordination means this neither superiority nor inferiority. First of all, let me tell you clearly. This means only vistas expansion. If I am civil engineer, I have to expand myself to some areas of electromechanical, some areas of electronics, just interactive organization work it is, and not to state that I should know thoroughly. At least I should have capacity to understand this item can be obtained from this discipline, and I have to contact that discipline engineer. It may be my own company engineer, same organization, or it can be vendors or subcontractors organization, whatever it is. And because I am a civil engineer and this is civil engineering project primarily, and I have duty to do that job, and until I get details from all those specific specialist engineers, electrical engineer, mechanical engineer, or some other engineer, whosoever, and I have to put inserts in my work. Inserts means something has to go in concrete, and that if information is not available, whether blockout is required or some conduits are required to be inserted in, or some other items are required to be placed in before concreting is done or before block work is done, whatever else. If I don't have that approval or that information duly approved, or I don't contact that engineer who is responsible for that item, services engineer, now how can I proceed on that job? And if I proceed on that job, it's my fault. I cannot say I didn't get information, I did it. Well, if I did not get information, I have no right to do that because it's question of time, it's question of money and cost. And of course, if I don't place that insert there in or some link to that service, this will not function. This project will not function to that extent. That point is really worrisome. I should forget at that time that I'm a civil engineer, I'm a mechanical engineer. I have to remember that my job is that this project should be delivered functionally. And functionally means that point also constitutes a part of functioning of project. And that's what I say. Coordination means, see, there are various types of drawings. One may say this is working drawing for structure, this is working drawing for mechanical, this is working drawing for heat, ventilation, air conditioning, and this is for water supply, sanitary, this is for this discipline, and this is for that discipline. We have all sets of drawing. Before doing some job, we use those drawings. Without approval of those drawings, approval means these are specific drawings. These are not original project drawings. These drawings are extracted from schematic drawings and converted to a state where work can be done. This means these details are more better than schematic drawings. These details are actual details. These are actual one, means these are based on what material we are going to use, what size of some item we are going to use, location of that one, how far from wall from here. And this you can say is actually a detail that has to be worked out on site, has to be implemented on site. And every other engineer who is responsible for that has to put in its information, and that's called working drawing or shop drawing likewise. And when we say on one plan we provide all this information, whatever is available, all interrelated services drawings are placed on one drawing and superposed on that. For example, we have civil landscape plan, we have to put all external services and internal services on that plan, just to ensure where clashes are seen. If clashes are noticed, then we have to correct those. This is an example, means that's called coordinated drawing. And in buildings, coordinated drawings are very important because of space restriction and because of time and because of we can't accept clashes between various disciplinary services. And that's why I can say this is to solve that. If there exist some clashes, if there exists some shortage of spaces vertically as well as horizontally, whatever, and services don't fit in according to rules and regulations or bylaws or according to court's information, we have to provide solutions to that. It may be vertical space in, say, we have false ceiling plenum, or it may be underground services or services in walls. Many services run there. For example, in buildings, specific buildings like hospitals, where tremendous and many services run here and there. In even ordinary buildings, we see services run. And sometimes spaces are too small. And that point we have to keep in mind. And based on experience, we have to solve these problems. And sometimes problems are so complex that it takes a lot of time for clarification or for confirmation. And that's why I say, if something is done at design time, when we design project, at that time, if some input is taken from those people who are experts in such disciplines, it may be better for future. But generally it is not done. Reason being that everybody runs on its own, and they say we'll look into this problem later on. Every time we say, okay, we'll take care of this later on, and that later on never comes. It comes only when work is done, and if nobody cares for that, nobody cares, and they do job, and that's what is done incorrectly, and later on they spend a lot of money on correction or remedial actions. And that's, we can say, is impact of coordination. If coordination is not done, it's negatively done, you have to face problems. And if coordination is positively done, we don't have to face that problem, but for that intellectual person is required, a person who can keep watch on everything, on every activity is required, a person who understands all disciplines, a person who can write clearly, who can communicate good messages, who can talk well, fluently, who can write fluently, who can coordinate with each other, who can represent in meeting and raise questions, and who can make notes or minutes of meeting, and then follow up with everybody. That person has got multiple jobs, multiple actions, at no planning issue, and planning is to be done accordingly. That person, you can say, knows specifications, that person knows drawings, and that person knows relevant codes. If not, information can be obtained from relevant working engineers. or those discipline engineers, and that information is studied well. And then final decision taken by responsible engineer who is responsible for designs of projects or supervision of projects, and that is called coordinated information. Of course, it takes some time, but that time is used when work is done smoothly without any problems, without being caused, and that's why working. It's not only the services are included in this coordination not only between services but also between architectural drawings and structural drawings, between internal and external landscapes, between all services and among services and related to structure, whatever. And that's important point, means there is no limit that coordination exists between two disciplines. It can exist among all disciplines. It doesn't give any specific formula. You have to understand whole project, and you cannot even depend on softwares. These days there are some softwares, but I can't trust them. So I not use them, but softwares you have to understand drawings. It's not necessary that practical aspect is considered by software. You have to be very clear that it's practical aspect, it's experience that helps, nothing else. And that's why I say quality is to be achieved by successful coordination, and successful coordination can be achieved by successful communication. Power of communication is very important in this regard, and that's why I put title here, power of communication, which is very, very important. If you see here in title of this, I put always real quality requirement, coordination engineering only way, no other way, and we say power of communication here in title. You can see that, and we also see reliable engineers, and those engineers who work on these engineers can't be, you can't be so, we may say, these are very confused sometimes, and sometimes listen this. Some confused because information is not available, and coordination is very important. It has to be done, can't be avoided. Just to keep coordination moving and project moving, it's important all the time. One should be busy until end of project. Because at end of project also coordination is among all documents, because these documents, hundreds of documents in each subdiscipline, and these documents to be piled up and coordinated for ease of those people who would maintain that structure after it's handed over or brought into commission. Maintenance cannot imagine what you did in those years of construction, but only papers, which we generally call in contractual term dossiers or documents or as-built documents, you may say. We may call it by whatever name. Generally, quality people call it dossiers. So you may say, okay, dossiers. Those dossiers should be crystal clear, see in sequence, and those people who deal with that in future, they don't find any problem in comprehending those details, and those details will be useful in future for purpose of maintenance, for purpose of upkeep, and if some repair is required, some failure happens, it can be investigated easily where mistake was done or no mistake was done. This is something else. That's why we have to keep ourselves, and generally, all records are maintained. There's no question not maintained. Every record is maintained on major projects, and it's only coordination that works there. So I can say coordination is a different type of engineering world. It's not specifically we can say this I'm perfect. Coordination means you are a multi-purpose person or engineer, you may say, because you have to be aware of, you have to study generally all documents in a way that you can say specialized engineer does. I'm not saying you have to go to formula or calculations, or you have to go to in-depth study of codes. This is not that one, but at least how work has to be done on site, that point or that requirement attracts coordination. And therefore coordination means you have to be busy in studying drawings, in studying specifications, and keep confined yourself what is planned and what goes on. If it doesn't mean you coordinate today and it's not going to be used for coming many months, other jobs are there which are going to be, you missed all them. So it's very interesting. In fact, once you immerse yourself in the coordination world, until you immerse yourself, you cannot say what problem exists. And maybe one or two problems you face, but later on you think you know what process there is, how it should be done and how can we move on. And that way you can say you can chart out what is real quality engineering and what is reliable coordination engineering, because information is available and quality system says that everything should be done according to requirement. And what about information of that item which is to be done? You have to get that information and then implement it with approval of everyone. We are going to do that later on. You cannot say I did not know this. Site engineer cannot say I did not know it, I was not given this information. Or discipline engineer says no, I was not given this information. That cannot be accepted. It is work which includes material, which includes quality, which includes time, and which includes every information should be put in or placed in before work is done. It's not only to you only as a coordinator, to site people also who work on sites in front, to supervisors, to foremen, and to charge hand. They should be given complete information so that they cannot say I was not given this information. So information means if you provide information to those people, it's called communication. Now it's up to you how do you communicate. Everybody cannot read, everybody cannot write, people listen, and if they listen in a way, it should be taught to them. It should be provided information in their own language. You can't use English everywhere, but information was provided in whatever is possible. And that's why you can say basis of coordination is information provision. The application of information is called, you may say, we can say quality environment. Yeah, we fix that, and that's what is required, fixing it. And then we say coordination engineering, as I said before, communication support, and that is reliable coordination engineering, which is very much important everywhere to be utilized. And it's very easy to say this project has been done, but what's the background of that? That's important. How much work was done on that, and how much concentration was included on that. And that's a very important point. That's a very important point, and that's why I try to explain all the time coordination. And we can say coordination is not clearly understood by many professionals, and others in its right required is spread. That point is very important, and fact remains that without adequate and efficient coordination in professional engineering, works cannot be successfully accomplished. I can say it shall be right to admit that coordination failure leads to engineering design and construction failure. This point we have to keep in mind that engineering design failure and construction failure means complete collapse of system, and then everything is lost, material is lost, cost is lost, time is lost, reputation is lost. So everywhere there is loss just for sake of coordination, just for sake of engineering information, good engineering design. This means designer has to be very smart while doing designing, just not confined to codes or confined to imaginations, but consult those people who experience, can tell you, can give you some benefit. You should share benefit of those experiences who have long experience on sites, on works, with those who know difficulty while doing job, while carrying out job, works, activities. And for many engineers I have observed that issue of coordination remains very delicate, and such engineers try to avoid coordination. They try to avoid involving with coordination, complexity. Just expect someone else should give final working drawings for work executions. This means those engineers they try to avoid headache job. They just want complete cooked food for eating. So this cooking means you give them complete information so that they, after getting it, study it, and hand over the charge, hand of foreman who can do job. Therefore, issue of coordination is very understandable, and those engineers who can do it, I think they are called smart engineers as far as I know. They should be called smart engineers because it is coordination. It's as important as taking food. If you can't take food, you can't work because you don't have energy. And same way, you may say coordination is soul energy, it is spiritual energy for job. I'm not talking of body's energy, I'm talking of mind energy. Coordination means fertile mind. Coordination means active mind. Coordination can be done by those who keep themselves immersed in that work. And once immersion is there, if you find some problems, certainly you will get some solutions. And if you are not able to get solutions, then some specialist will solve you, provided that specialist has provided comprehensive coordinated information. And that's sole purpose of coordination. And I've experienced that from around the world. There are many engineers I've seen, and I can say major population of those engineers do not have any interest in working on coordination activities due to relative respective interest, due to respective you can say requirements or essential requirements you can say on concentration or on concentrating or focusing constantly on engineering and in-depth technical issues. These problems cannot be counted in numbers but in consideration or in considering gravity of whatever work items are involved. Coordination definition is for sure necessary to be understood for its real meaning so that no mixing results in. You should remember that coordination is done in every profession, in every field. Way may be different, points may be different. And where coordination is not done, then we can say that inefficiency comes in. Nobody knows how work shall be done, and because nobody knows, they just beat about bushes. They don't come to a point. This means time is lost. You do not know what to do. You keep on doing meetings. You don't consult respective and real person or linked person. And then you want to reach some agreements. And if you try to reach some agreement, that will be futile work because you do not know what to do. And by doing coordination, you will find every required information is available. And if something is not available, then you can raise that issue. This information must be procured from whatever reliable source. Coordination definition is for sure necessary to understand. That's how can we understand this. Mixing means a state of confusion. We can't rely on state of confusion in whatever work. And this state of confusion meaning indicates that right activity related to work cannot be carried out at right time. And that is what meaning of coordination is, that you have to use whatever information. Sometimes you have information in advance, so that's worrisome or no. You have to say, no, that's good. But there could be some change as well on that till your work is done. Definitely in that case you have to re-coordinate. Maybe there's some change or you have to study it again. So even for a small building, I can say, even for a small building there can be many number of drawings, architectural drawings, structural drawings, other drawings. And we have to therefore coordinate. We cannot just say, okay, do it and leave it. You cannot start because it can affect your engineering works. It can affect your, you can say, orientation of activity. It can affect alignment. It can affect whatever. And that's why being a good practitioner, one should be clear about what is to be done. And coordination is a way. Of course, it requires some input from engineer, but input is that beneficial because it helps you do work faster. And of course, sometimes there are activities which are in parallel to current activities or which are dependent in sequence, and you do not understand what will happen, which will come first in that case. Because you have studied it properly, you have consulted with people who will work it. So that dilemma, what to do, does not exist. For coordination, therefore, we can say it depends on designing professional also about how to apply drawings and detailings so that construction personnel should not refer back all times, every time, for either confirmation or clarification of various issues involved. We can say in that case coordination can therefore be defined in a way that all branches of engineering and all disciplines involved in ongoing activity must be clearly described and detailed in, so that no information is left out that could hold progress on activity or part of whatever activity. If even one small information is held without having adequate details or is not formally confirmed, activity can stop or it shall be carried out based on either correct or incorrect knowledge possessed by that site team, which work if done could be considered in contravention of what designing team contemplated. Consequently, it shall be certainly leading to cause formal errors. And errors are not positive. Errors means loss of something. It also remains a fact that no subject or no branch of coordination engineering is available for imparting professional education at whatever or any either diploma or degree level, and even if it may be considered up to doctorate level, but coordination is independent of all. It is a requirement. It's not, you can say, privilege. It's a requirement. It's a mandate. The understandable mandate, procedural mandate, and this is very much, technical, very much engineering based, and can be logics only, no hypothetism, no imagination. Whatever information we get, that should be logical based on some factors. So we can say absence of inclusion of this significant subject within engineering programs explicitly indicates and evidences that education professionals do not understand the value of engineering coordination discipline. And I won't say it's fault of someone, I don't want to go into that, but I would say only coordination. Engineering is an unlimited world. It can expand its vistas to unlimited areas involving many disciplines in one branch of engineering, and also importing various branches of engineering depending on what class of work it is. And particularly when we deal with contracts. When we deal with contracts, it's very much important, because signing contract is one part, but doing or implementing contract is another part. And there's no specific clause that you have to do coordination like this. You have to decide yourself and get it in consent with that person, engineer, who is responsible for whatever procedure. Because once what you want to do is clear, it can be done easily if it is well understood, and that information can be given to whosoever are responsible for carrying out job. That's a very important point, and I will say particularly on contracts, construction contracts or design contracts, it's very important one. There may be design defaults, there may be design faults, there could be anything, and we have to go through that. We have to go through that not because we want to punish someone. We have to go through that we want to see work is done safely, securely, and there should be no repetition on that. Repetition means again you break something and make again. It doesn't work. And that's why coordination is very important part in life. I try always that you have to be very careful, and coordination engineer would have been appointed had incumbent professional been experienced on considerable size project site. And whosoever professional having just one engineering discipline knowledge could not be successful for efficient working on site, and progress consequently either marred or errors caused. Such unhelpful situation forced professional engineers to work long hours to have firm grip of design details, and correlated one discipline with other disciplines one by one, of course consuming considerable work allotted time, and understanding of coordination definition and respective description makes certain difference on works cannot be done effectively by team, but certainly by perfect getting through all related details available of schematic designs as well as on other conventions or so-called on other documents, designs as well as on other documents, and of course professional market prevailing conventions or so-called good in digital practice. And of course members of project team are required to extend engineering support to engineering coordinator, without whose input no coordination activity will move, whereas engineering professional involved on every coordination has to involve corroboratively or had to involve personally on every provided information for purpose of corroborative ratification based on total scrutiny as well as necessary examination or investigation of all details. Coordination is a never-ending activity which therefore cannot be considered time-fixed activity. It depends on design mandate and scope requirement along with other contract documents such as engineering design specifications and acquired input from spatial materials, producing manufacturers such as documented instructions and material data studies, complexities of technicalities and structure of resources, have certainly created additional complexities. When many disciplines or branches of engineering work together, forcing attention from coordinating professional to look into all requirements, contract related and industry related, as well as codes mandate related. In fact, coordination at higher level of responsibility is always a voluminous task. Which work imports working knowledge of various engineering branches and additional in-depth knowledge of one sound engineering discipline. It's also true that in current engineering and advanced project scenario, just depending on certain proclaimed software may not be absolutely assistive to automatically resolve details pertinent various conflicts among various disciplines, and therefore no blind eyes can be allowed to thrust outcome of various conflicting details into physically workable solutions. As many items on various components of whatever project do invite equivalent, additional or augmentative level of coordination for all such designs and respective detailing applications. On-site work depend on finally agreed details which we sometimes name or entitle current documents under proposal and then approval as such working drawings, and also shop drawings, and final to cover all disciplines in an unified approach coordination drawings. Such activities to produce coordination drawings on various areas of project components and where coordinator has to apply mind fully immersed in an imaginative contemporary ocean of details, keeping abreast applicable specifications and contract related documents, and of course contractual complexities that make entire situation little more complex, and in certain cases a major overhaul requires to be effected. It is really disappointing to note that coordination preference has been found missing among engineers at beginning of professional career. When one tries or opts to specialize just on its own discipline, even discarding its own branch related other subjects. It's of course necessary for professional to be for sure attain at some specialization level, but simultaneously must move on parallel tracks with remaining disciplines and certainly try to join other engineering branches overlapping. Herein, at this stage of conferring, I shall like to infer with entitled terms such as specialist engineers, managers, organizers, as well as others. It's also admissible that every professional engineer must have associated certain ambition to achieve and to reach certain goal in professional world. But it does not mean that such professional shall have to leave all other aspects that apply within profession for cohesive working. Focus should not find any final stop, but continuation of specialization and then additional working specialization as major requirements in engineering profession, because engineering cannot be replaced or overtaken by any other non-engineering professional. I'll go to some more file, that's concrete specifications we were busy in, and I'll open that one for reference because we're talking of coordination, and coordination means everything I can say coordination is that one. We'll go to page 95, I think, I remember. So here is so we are here somewhere, we may say lightweight aggregate we're talking of. I think it is some more. So yes, we are somewhere here, and we'll go from here onwards to first time. Now let me see time factor also. It's about 22 minutes only. Oh, it is. 48 minutes. I'm sorry, there's some error here. Still, signals being problematic. That's 0, well, some signals again came. So, you may say, here I give you some definitions. It's page 293. And we constructing, let me see what's written in this. Constructing special concrete. Just a minute, please. constructing special concrete, discussed on materials and construction. Special concrete frequently requires professional skills. It is stipulated that special concrete should be constructed under guidance of professional engineers with adequate knowledge and experience concerning specific types of special concrete. Acceptance tests for special concrete discussed in materials and construction. Special concrete shall be conducted either by contractor or owner according to type of concrete. When acceptance tests for special concrete are conducted by contractor, engineer or owner needs verify results of inspection. Responsibilities of contractor and owner should therefore be defined as well. Expensive concrete, expensive admixture, chemical pre-stress, chemical pre-strain, chemical pre-stress, chemical pre-strain, shrinkage compensation concrete, chemical pre-stressing concrete, shrinkage compensated concrete, chemical pre-stress concrete, lightweight aggregate concrete, surface dry state of lightweight aggregate, specific gravity of surface dry lightweight aggregate, pre-wetting continuous fiber reinforcing material, continuous fiber tension, continuous fiber binder, short fiber reinforced concrete, steel fiber reinforced concrete, synthetic fiber reinforced concrete, short fiber content, steel fiber content, tension, softening, curve, explosive fracture, unit volume of dry rotted coarse aggregate, high fluidity concrete, self-compactability, segregation, resistance, flow ability, pass ability, then viscosity agent, unit absolute volume, and shotcrete, lining concrete, wet spraying, dry spraying, set accelerating agent, percentage of rebound, dust concentration, pre-packed concrete, grouting mortar, minimum size of coarse aggregate, underwater concrete, stabilizer, anti-washout underwater concrete, underwater washout resistance, test piece made in water, test piece made in air, strength ratio of underwater concrete, pre-stress concrete, pre-stressing steel, pre-stress, tendon, duct, sheath, anchorage fixture, pre-tensioning, post-tensioning grout for pre-stress concrete, internal pre-stressing method, external pre-stressing method, deviation fixture, deviation zone, concrete product, moist curing, insulated curing, accelerated curing, steam curing at atmospheric pressure, autoclave curing, centrifugal compaction, casting, instant demolding, hot concrete. So admixture is added. Expensive admixture that is mixed with cement and water to generate ethringite or calcium hydroxide, concrete to expand, calcium hydroxide for concrete to expand, chemical pre-stress, compressive stress that is applied to concrete when expansion of expensive concrete is restrained. Compressive stress that is applied to concrete when expansion of expensive concrete is restrained by such objects as reinforcing bars. Chemical pre-strain applied to restraining objects when expansion of expensive concrete is restrained by such objects as reinforcing bars. Shrinkage compensating concrete Expensive concrete when with expansion capacity to offset or reduce tensile stress caused by drying shrinkage using chemical pre-stress. Stress shrinkage compensating concrete. Then chemical pre-stressing concrete. Expensive concrete with expansion capacity sufficient to leave chemical pre-stress even in case of drying shrinkage. That is chemical pre-stressing concrete. Expensive concrete with expansion capacity sufficient to leave chemical pre-stress even in case of drying shrinkage. Shrinkage compensated concrete or reinforced concrete to which chemical pre-stress is applied. Reinforced concrete, this was shrinkage compensated concrete, means reinforced concrete to which chemical pre-stress is applied to offset or reduce tensile stress caused by drying shrinkage, mainly by using shrinkage compensating concrete and restraining expansion of concrete with reinforcing bars or other materials. Chemical pre-stress concrete, reinforced concrete to which high expansion capacity is provided, mainly by using chemical pre-stressing concrete, so that chemical pre-stress that is introduced into concrete by restraining expansion, chemical pre-stress that is introduced into concrete by restraining expansion, and chemical pre-strain that is introduced to reinforcing bars remain even where chemical pre-stress and pre-strain are partly eliminated by drying shrinkage. Lightweight aggregate, a kind of aggregate whose density is lighter than that of normal rock. A kind of aggregate whose density is lighter than that of normal rock, used for reducing concrete weight or for purpose of thermal insulation, etc. Lightweight aggregate concrete. Concrete with specific gravity lower than that of normal concrete, produced using lightweight aggregate. Surface dry state of lightweight aggregate. Surface dry state of lightweight aggregate. State of lightweight aggregate in which only water on exposed surface is removed from its wet state. Specific gravity of surface dry lightweight aggregate. Density of a lightweight aggregate particle in a surface dry state. Pre-wetting, work of soaking aggregates before using. Continuous fiber reinforcing material. Pre-wetting was what? Work of soaking aggregates before using it. Continuous fiber reinforcing material. Concrete reinforcing materials made of continuous fibers bound together by adhesive. They can be unidirectional reinforcing materials, round up or wove continuous fibers. Continuous fiber tendon, continuous fiber reinforcing material used for applying pre-stress on concrete. Continuous fiber for reinforcing concrete, such as carbon fiber, aramid fiber, and glass fiber. That is continuous fiber for reinforcing concrete, such as carbon fiber, aramid fiber, and glass fiber. Fiber binder that solidifies fibers, plastics such as epoxy resin and vinyl ester resins. Short fiber reinforced concrete, steel fiber reinforced concrete, or synthetic fiber reinforced concrete. Steel fiber reinforced concrete, made by mixing steel fiber into concrete, mainly to improve its toughness and abrasive resistance. Synthetic fiber reinforced concrete, concrete mixed with synthetic fiber mainly to enhance effectiveness of preventing explosive fracture or spalling. Short fiber content. Volume percentage of short fibers per cubic meter of short fiber reinforced concrete. Steel fiber content. Volume percentage of total volume of steel fiber present in 1 cubic meter of steel fiber reinforced concrete. Tension softening curve expressing relationship between tensile stress and crack width. Explosive fracture. Delamination, explosive fracture, delamination or spalling. Delamination, spalling of concrete surface when concrete is subject to fire. Unit volume of dry rodded coarse aggregate. Bulk volume of coarse aggregate to produce 1 cubic meter of concrete. Bulk volume of coarse aggregate to produce 1 cubic meter of concrete. It's obtained by dividing unit weight of coarse aggregate into its weight per unit bulk volume. High fluidity concrete with greatly enhanced flowability but still possesses high resistance to segregation. Self-compactability. High fluidity concrete with great enhanced flowability but still possesses high resistance to segregation. Self-compactability. Property of fresh concrete to uniformly fill all corners of formwork by its own weight without requirement of external compaction. Segregation resistance. Property of fresh concrete that enables to maintain its uniform distribution and avoiding segregation of constituent materials under gravity or application of external forces. Segregation resistance is property of fresh concrete that enables to maintain its uniform distribution, that is avoiding segregation of constituent materials under gravity or application of external forces. Flowability, property expressing level to which fresh concrete moves under gravity or application of external forces. Pass ability for narrowed areas. Ability of fresh concrete to pass through narrowed gaps between reinforcing bars and fill up space by its own gravity without risk of segregation. Viscosity agent. A type of admixture that increases viscosity and segregation resistance. Some of them have ability to reduce variations in quality of fresh concrete. Unit absolute volume of coarse aggregate. Unit absolute volume of coarse aggregate. Value is obtained by dividing unit content of coarse aggregate by its density in saturated surface dry state, that is meter cube per meter cube. Shotcrete, concrete conveyed by compressed air using pump or compressor through conveying hose and sprayed from nozzle at end of hose onto target surface. Concrete conveyed by compressed air using pump or compressor through conveying hose and sprayed nozzle at end of hose into target surface. Lining concrete. Cast in place concrete inside shotcrete. Cast in place concrete inside shotcrete sprayed into in a tunnel constructed by drill and blast method. Concrete is generally unreinforced where lining is subjected to earth pressure or asymmetric pressure. However, reinforcing parts are used for reinforcement. Wet spraying of concrete mixed with all materials using compressed air. Dry spraying of dry mixed materials by pumping them using compressed air and adding designated amounts of water at end before spray nozzle. Wet spraying was spraying of concrete mixed with materials using compressed air, and dry spraying is spraying of dry mixed materials by pumping them using compressed air and adding designated amount of water at and before spray nozzle. Self-accelerated agent. Chemical admixture added to shotcrete in order to shorten setting time and increase the entry strength of shotcrete. Set accelerating agent. Chemical admixture added to shotcrete in order to shorten setting time and easing early strength of shotcrete. And percentage of rebound. Percentage of mass of concrete that rebounds without being attached to surface in total mass of concrete. Dry spraying is spraying of dry mixed material by pumping them using compressed air and adding designated amount of water and before spray nozzle. Set accelerating agent. Chemical admixture added to shotcrete in order to shorten setting time and increase early strength of shotcrete. Percentage of rebound. Percentage of mass of concrete that rebounds without being attached to surface in total mass of concrete sprayed. Dust concentration. Mass of solid fine particles that rebound or fly from nozzles and float in air during spraying. Dust concentration. Mass of solid fine particles that rebound or fly from nozzle and float in air during spraying, expressed in milligrams per cubic meter of air. Prepared pre-packed concrete. A kind of concrete produced by packing coarse aggregate particles of a specified grading and formwork and grouting mortar between voids of pre-packed aggregate. Grouting mortar. A mixture of cement, fly ash or other mineral admixtures, sand, chemical mixture and water used for injection into pre-packed concrete. Minimum size of coarse aggregate. Size of coarse aggregate is specified by nominal size of largest of all sieves on which at least 95% by weight of aggregate is retained. Minimum size of coarse aggregate. Size of coarse aggregate specified by nominal size of largest of all sieves on which least 95% by weight of aggregate is retained. Underwater concrete. concrete used for construction under normal water, slurry or seawater. Stabilizer, liquid used mainly for preventing collapse of tunnel. Liquid used mainly for prevention of tunnel, collapse of tunnel, walls, composed mainly of water and also of bentonite and polymer. Anti-washout underwater concrete. Underwater concrete with segregation resistance enhanced by using anti-washout admixture. So anti-washout underwater concrete with segregation resistance enhanced by using anti-washout admixture. Underwater washout resistance, ability of preventing segregation under washout action of water. Test pieces made in water. Test pieces made by dropping anti-wash water. Test piece made by dropping anti-washout underwater concrete into mold placed underwater as specified. Test piece made in air. Test piece made by filling anti-washout underwater concrete into mold or in air or as specified. Strength ratio of underwater concrete to normal concrete. Compressive strength of test piece made in water to test piece made in air at same age. Pre-stress concrete, a type of reinforcement, a type of reinforced concrete. Reinforced concrete pre-stressed by means of pre-stressing of steel. Pre-stressing steel means high strength steel used to pre-stress concrete. Pre-stress stress introduced on concrete before application of service loads to reduce tensile stresses induced in concrete by loads. Tendon, a pre-stressing bar or strand. Duct, space created through concrete of a post-tension pre-stress concrete member for enclosing a tendon. A case that forms a duct, that is sheath, a case that forms a duct. A case that forms a duct. Anchorage fixture, a fixture for anchoring ends of tendon to concrete for transmitting pre-stress to member. Connection fixture, a fixture for connecting one tendon to another. Pre-tensioning, placing concrete while tendons are provided with tension and transmitting tension provided to tendons to concrete through bond of tendons and concrete after hardening of concrete to apply pre-stress. Post-tensioning, providing tension to tendons after hardening of concrete and apply pre-stress by anchoring ends of tendon to concrete. Grout for pre-stressing. Before this pre-tensioning, let's say pre-tensioning, placing concrete while tendons are provided with tension and transmitting tension provided to tendons to concrete through bond of tendons and concrete after hardening of concrete. Pre-tensioning, providing tension to tendons after hardening of concrete and applying pre-stress by anchoring ends of tendons to concrete. Grout for pre-stress concrete. A mixture of cement, water and admixtures to fill the gap between duct and tendons after pre-stressing in post-tensioning. Internal pressure method. Method of pre-stressing using tendons placed in concrete member. External pressure method. Internal pre-stressing method of pre-stressing using tendons placed in concrete member. Deviation fixture, a fixture used for maintaining or deviating position of tendon in external pre-stressing method. Deviation zone, a zone where deviation fixture is fixed to concrete member and a component of tension generated by deviating tendon is transmitted to member. Concrete product. Precast concrete product. Precast concrete products manufactured in succession in control factories. Concrete product. Concrete product, precast concrete products. Precast concrete products manufactured in succession in controlled factories. Moist curing, a method of curing where concrete is kept in moist condition for a certain period of time after placing. Insulated curing, a method of curing where necessary temperature is maintained by utilizing heat of hydration of cement and preventing escape of heat to utmost by covering surface of concrete with highly insulating material. Suraj_engineer@yahoo.co.uk, and here accelerated curing, a curing method used to accelerate hardening process and strength development of concrete. Steam curing, an accelerated method of curing concrete An accelerated method of curing concrete in water vapor at high temperature, that's called steam curing. Steam curing at atmospheric pressure, steam curing at atmospheric pressure. Autoclave curing, a method of curing in a steam boiler. A method of curing in a steam boiler, which is called autoclave at high temperature and high pressure. So the steam curing is there, then there is steam curing means accelerated method of curing in water vapor at high temperature, that's steam curing, and steam curing at atmospheric pressure, and autoclave in steam boiler, high pressure, high temperature. Centrifugal compaction, compaction of concrete by centrifugal force using a formwork revolving at an extremely high speed. Centrifugal compaction, compaction of concrete by centrifugal force using a formwork revolving and at an extremely high speed. Casting, production of factory products, production of factory, I can say generation of factory products by placing concrete into a form and applying compaction to placed concrete. Instant demolding, removal of a part of all, removal of a part or all of formworks, removal of a part or all of formworks for concrete within extremely stiff consistency immediately after placing and compacting using strong vibration or pressure. Instant demolding, removing a part of all formwork for concrete with an extremely stiff consistency immediately after placing and compacting using strong vibration or pressure. Hard concrete, concrete product of which temperature is over 40 degrees Celsius. Hard concrete product which temperature is over 40 degrees Celsius immediately after completion of mixing. Has some commentary in this connection. We have lightweight aggregate. Lightweight aggregate is classified into artificial lightweight aggregate, natural lightweight aggregate. One is artificial, one is natural, and byproduct lightweight aggregate. In this specification, only structural lightweight aggregate, which is consistent in quality and can be used for making lightweight aggregate, is dealt with. Surface dry state of lightweight aggregate. Surface dry state of lightweight aggregate. For ordinary aggregates such as river sand, river gravel, and crushed stone, saturated surface dry state is defined as one of standard state of their moisture content to be considered in expressing specified mix and other matters. River sand, river gravel, and crushed stone. Saturated surface dry state is defined as one of standard states of moisture content to be considered in expressing specified mix and other matters. In case of lightweight aggregate, however, it is almost impossible to obtain its saturated surface dry state. In case of lightweight aggregate, however, it is almost impossible to obtain its saturated surface dry state, because lightweight aggregate generally absorbs much water and it takes a long time to saturate insides of aggregate particles. Accordingly, in case of lightweight aggregate, state in which Only parts near surfaces are nearly saturated with water, and there is no water on surface. Even if inside of aggregate particles are not saturated, is defined as surface dry state. For practical purposes, this state is stated as state to which saturated surface dry state of ordinary aggregate corresponds. Surface dry state of lightweight aggregate is not a constant one, and it shall be noted that specific gravity in a surface dry state varies depending on degree of water saturation. Pre-wetting aggregates in dry state absorb water of concrete during mixing and transporting. Pre-wetting aggregate in dry state absorb water of concrete during mixing and transporting. In order to minimize degree of water absorption, it is necessary to conduct work of soaking aggregate in water before using it. This operation is called pre-wetting. Continuous fiber reinforcing materials. Continuous fiber reinforcing material is generic name of a material made of continuous fibers tied together by fiber binder for use as reinforcing materials in concrete instead of steel bars or pre-stressing tendons. Steel continuous fiber reinforcing material. Continuous fiber reinforcing material is generic name of a material made of continuous fibers tied together by fiber binder for use as reinforcing material in concrete instead of steel bar or pre-stressing tendon. Continuous fibers like carbon fiber, aramid fiber, glass fiber, or nylon fiber. Steel fiber content. Steel fiber content. Reason for expressing content of steel fiber in unit of volume percentage of steel fiber in 1 cubic meter of concrete is that volume not weight of steel fiber in matrix is most directly influencing factor of strength and deformation in steel fiber composite material. Tension softening work. It is believed that at crack tip, this so-called fracture process, tension soft curve, believed that at crack tip, that's also called material. Tension softening curve. It is believed that at crack tip there is a so-called fracture process zone governed by on formation and development of micro crack. It is believed that at crack tip, there is also so-called fracture process zone governed by one of formation and development of micro crack. Fracture process zone is classified into micro cracking zone with many micro cracks such as peeling of mortar at surface of aggregate and bridging zone with aggregates or steel fibers laying across crack. Tension softening curve. Tension softening curve shows relationship between tensile stress transferred in fracture process zone at crack tip and crack width. It is, you can say, fracture process shown, this is crack width and this is tensile stress. Means width increases and tensile stress decreases. Its size least width means highest tensile stress. And these are two zones. Then this is, you can say, micro cracking zone, and this is bridging zone here in between, and this is other one, fracture process zone. So there are two one, and this is here is given bridging zone, fracture process zone. High fluidity concrete. Definition of high fluidity concrete is in fact definition used by Japan Institute of Architectural Institute. High fluidity concrete. However, high fluidity concrete on this specification indicates one with self-compactability. Passability for narrow areas. Possibility for narrow areas. That was high fluidity concrete and possibility of areas. Ability of fresh concrete. Ability of fresh concrete which passes and fills into narrowed areas such as space between reinforcing bars by its own weight without need of external compaction. Pass ability can be approximately measured by U-shape filling test. Ability of fresh concrete which passes and fill into narrowed areas such as space between reinforcing bars, its own weight without requirement of external compaction. Pass ability can be approximately measured by U-shape filling test, box filling test, or funnel floor test. Absolute volume of dry rodded coarse aggregate. Absolute volume of dry rodded coarse aggregate per unit volume of concrete and bulk volume of coarse aggregate. Absolute volume of dry rodded coarse aggregate and dry rodded coarse aggregate per unit volume of concrete and bulk volume of coarse aggregate per unit volume of concrete. These values must be considered during mixed design because these affect self-compactability of high fluidity concrete or passability. Generally, an absolute volume of dry rodded coarse aggregate per unit volume and bulk volume of coarse aggregate per unit volume of course will become small. But to say, generally, an absolute volume of dry rodded coarse aggregate per unit volume and bulk volume of coarse aggregate per unit volume of concrete becomes small. Young's modulus of high fluidity concrete becomes lower. Young's modulus of high fluidity concrete becomes lower. Therefore, appropriate value must be determined. Value of coarse aggregate per unit volume of Concrete depends on density of coarse aggregate, even if absolute volume of dry loaded coarse aggregate per unit volume is same. Pre-packed concrete, coarse aggregate of specific grading. Coarse aggregate of specific grading means one which contains a little amount of particles passing 15 mm. Coarse aggregate of specific grading means one which contains a little amount of particles passing 15 mm. Special mortar means mortar which possesses such properties as high flowability, little segregation and small shrinkage and expansibility. Minimum size of coarse aggregate. Terms minimum size of coarse aggregate does not mean minimum size of smallest particle. This definition was given based on reason that it's not practical and improper to determine actual minimum size by measuring individual minimum size of particles. Since coarse aggregate contains particles with various shapes, this term is used only in case of pre-packed concrete. Concrete product. Some examples of concrete products are hewn pipes, piles, blocks, railroad sleepers, shield, segments, and precast composite slab. These are mass produced in succession in factories for different applications. Concrete in factories are usually called factory product. Precast product, concrete fabricated products. In this case, moist curing is to ensure necessary amount of water for hydration of cement is in concrete stems. It's not sufficient just by preventing evaporation of water from placed concrete. This curing method is also effective in preventing cracking down to drying shrinkage during initial hardening stage. Temperature control curing. Curing method is to control temperature in each part of concrete to facilitate normal hardening process and to avoid cracking after hardening, as well as and to develop excesses internal stress. In utilizing this curing method, that is temperature control, it's necessary to take into account both sizes of members and effects of construction conditions. Accelerated curing. There are some curing methods to accelerate hardening rate of concrete, such as steam curing, autoclave curing, hot water curing, electrical curing, infrared curing, and high frequency curing. However, in general, steam curing is widely used. Steam curing is usually conducted at lower temperature than 35 degrees. Such curing is that to maintain temperature of concrete at lower temperature than 35 is not included here. Centrifugal compaction. Centrifugal compaction is used for placing of concrete parts of hollow cylinders such as bowls, piles, pipes, and so on. Effect of centrifugal compaction is related to magnitude of force originated by revolution of formwork. Acceleration of centrifuge usually by up to 10 to 24 g. Casting in production of concrete. In production of concrete products, process of placing concrete into formwork, and then providing compaction to placed the concrete is called casting, while stripping formwork is called demolding. In production of concrete products, process of placing concrete into formwork and then providing compaction to place concrete is called casting, while stripping formwork is called demolding. Hard concrete of a temperature of 40 to 60 degrees Celsius is used to place in a formwork and remove formwork in a short time after hot curing. Expensive concrete. Expensive concrete specifies standards on essential matters particularly required for achieving required qualities and performances of expensive concrete. Expensive concrete referred to in this chapter are shrinkage compensating concrete and concrete for chemical processing. Expensive concrete is general term for a type of concrete which consists of expensive admixture mixed together with cement, water and fine aggregate, coarse aggregate and other admixtures, and which processes volumes expansion even after start of hardening. Various